What's up guys, Onmaths here, and today we're looking at cumulative frequency. So this first question from AQA asks us to draw a cumulative frequency graph, but it only gives us a frequency table or grouped frequency table. So we've got to first of all convert that table into a table that we're going to use for the cumulative frequency graph. Now cumulative frequency, the word cumulative means that it grows as it goes along. So a cumulative frequency graph will never go down. You're only ever going to go across or up because it's constantly adding and adding and adding. So what we're going to do is we're going to try and fill out this table on the right. Now this first column is going to be our upper bound, and that just means where's the maximum that x can be. So this first one, the maximum that x can be is 50. Then this next one, the maximum x can be is 60, including that 40 to 50. So it's all the ones below 60. This next one is all the ones below 70. And this last one is all the ones below 80. This next column is the cumulative frequency column. And we're looking at all the x values less than 50. Well, that's just 6. But for the next one, it's the 6 plus the 16. Okay, so we do 6 plus 16 and we get, 22. Then we're going to add on the 28 from that 22. So we're just adding on as we go down, and that's 50. Then we're going to add the 10, and that's 60. Now this last number here should be the total amount of whatever it is that the question's on about. And this is talking about cars, so this should be there's 60 cars. And if you look at the question, it says that there's 60 cars. So we know we've got it right if we end up with 60. Next, we have to plot this onto our graph. So what's the first one? 6 and 50. So we go to the 50 and we go to 6. Now this is going up in 2, so 6 is here. And we put a cross at that point. Okay. Notice that we're always plotting against the maximums in each group. Okay, and this is shown in the upper bound column here. So the next one's 60 and it's 22. So 60 and 22 will be here. So it will be here, and I can probably get that a bit better. There we are. Next one is 70 and 50. So 70 and 50. And then the last one is 80 and 60. Now, what's really common for people to do is plot the first one, say at 45, then 55, then 65, then 75. That's a frequency polygon, not a cumulative frequency graph. So frequency polygons are plotted at the midpoint and aren't cumulative frequency, so you just plot the frequencies. But cumulative frequency graphs plotted at the maximum on each group, and you add the frequencies as you go along. As I said, it can only go across or up. It can't ever go down. The second mistake I see with these is that these are drawn as bars. That would be a histogram if these were drawn as bars. So if you drew a bar between 40 and 50 and made it 6 high, then it would be kind of a histogram. So just be careful of that. Right. Now we sometimes some teachers say that there's a missing point here, and we know that x can't be less than 40. So what some teachers say is plot the 40 there. Now it's quite common to not get a mark and not lose a mark for that. So you can leave it up to your own instincts whether you're going to plot that 0 point. Now, next controversial thing is that die-hard mathematicians would say this needs to be joined with a curve, that it's not mathematical if it's not joined with a curve. However, the exams will let you join these up with straight lines and draw this as a polygon rather than a curve. So you use your best instincts on this. Some people have bought bendy rulers that are specific for drawing curves, and that helps with this, but it takes a lot of practice. But on all the exams, will get full marks if you just join each of these points up with straight lines. Now, it's up to your teacher, really, to decide whether they want you to do that. because in real maths, when you leave for the real world and start doing cumulative frequency graphs in real life, you'll see them done as curves. You won't ever see them joined up with straight lines. But that's done with computers now, so computers can work out what the curve needs to be based on the points. So yeah, leave that up to you. But you will get full marks for not plotting the point here, and for joining them up with straight lines. So just bear that in mind. Now, next we're asked to do the interquartile range. So first of all, we need to figure out what the quartiles are. So there's a nice way of doing this. If you look at your maximum point, and that is not the maximum point of the graph. So if there was a 70 there on the graph, 70 would not be the maximum point. The maximum point is the maximum point in which the cumulative frequency graph reaches. That's that point there. Then if you halve it, that will show you how to get the median. That 30 is not the median, but that will show you how to get the median. And you'll see what I mean in a second. Then if you halve that again, that will show you how to get the lower quartile. Now I'll do LQ. You could write Q1 for that. And if you add that 15, which I've just plotted, and the 30 together, so that's 45, that will show you how to get the upper bound, or upper quartile, sorry. Okay, and sometimes you'll see that as Q3. Now, I've been very careful not to say it's not the lower quartile, it's not the upper quartile. It shows you how to get it. Okay, and we'll see what that means in a second. So to get the lower quartile, what we do is we draw a straight line across from where we've just put a little notch on the y-axis, and we keep going till we hit our line and go down. Okay, now that's not very precise. Let's try and get that a little bit more precise. And I'm starting to move the lines there. So if I draw that, that looks about 55 there. If I do the same on the other one, and the screen I'm using is not perfectly calibrated, but should be able to, there we are. That looks, I mean, if I drew that properly, that looks about, what, 68. Okay, so our upper quartile is 68, our lower quartile is 55. So what we do is we get that 68, the upper quartile, and we just take away the lower quartile. That gives us the value of 13. So our answer is 13 for that. And I think that's it, yeah, that's it for the question. So yeah, that's how to find the median and the upper quartile and the lower quartile. Just try and be careful with reading this off, and those lines I've drawn on the graph there are essential. You have to draw that. For instance, I think on this exam, from memory, the actual answer was not given at all anywhere. The marker had to see your graph and see whether you read it right, and see whether you picked the right numbers, and see whether your interquartile range is correct for the graph you drew. So you have to show the examiner how you got that. Next we move on to this OCR question. Now I've made this a little bit smaller just so we can fit the cumulative frequency graph all on the screen. But essentially this is just saying this cumulative frequency graph of the speeds of cars going along a road. And a speed camera is going to be installed if 30% of the vehicles go over the speed limit of 40 miles per hour. Use information in the graph to decide if the speed camera should be installed. So the first thing we're going to do is figure out how many cars are going above the speed limit, which is 40. So we're just going to draw a line up from 40. Okay. And a line across. And that's at 55. So that means 55 cars on the cumulative frequency graph are going at 40. Okay, so that is the amount that is less than 40. Okay, and this is really important we understand this with the cumulative frequency graph. That's the number of cars going less than 40. So if you look at all of this down here, all those cars are going less than 40. Okay, so we've got to figure out how many cars there are in total. So in total there's 80. So there's 80 cars in total, and 55 are obeying the speed limit. So we've got to do 80 take away 55, which is 25. So there's 25 cars not obeying the speed limit. Now we need to see whether that's more than 30%. So there's two ways of doing this. The first way is to convert that into a percentage. So 25, so the amount that's disobeying the speed limit, over the total amount, which is 80 times 100. And that will work out as a percentage. So I'll get my calculator out. 25 divided by 80 times 100. And that gives me 31.25%. And that's absolutely acceptable answer. It says use to decide should be installed. Okay, so we need to actually write down an answer. So that 31.25% is above the 30% here. So yes would be our answer. I said there were two ways. The other way of doing it is you can work out how many vehicles of the 80 need to disobey the speed limit for us to install the speed camera. So I'm going to do this in a different colour because you don't, the red stuff or the pink stuff you would get full marks for. So this is a kind of alternative method. So we're going to find 30%, which as a decimal is 0.3, and we're going to times that by the amount of cars, so 80, so 0.3 times 80, and that gives us 24. So we could have had 24 cars, and that would be exactly 30%, but here we have 25 cars, therefore, yes, there are 25 cars. We could have only had 24, or it was going to be 24 cars or more, because 24 cars was 30%. Last up is our Edexcel question. This is quite a lengthy question. So for this question, we need to, first of all, get information from a cumulative frequency graph, and then we need to use that information to draw a box plot. Okay. Now you need 5 things to draw a box plot. You need the smallest amount, the lower quartile, median, upper quartile, and then our largest amount. Now, thankfully, we're given the smallest and largest amounts, but we still need to find the quartiles and the median. Okay. So the first thing to realise is that the graph goes up to 48. So to find the median, we halve that. Half of that would be 24. And so we draw a line across and down. So the median is 10. Then we halve that 24 and we get 12. So the lower quartile will be at 12. So we do the same thing, line across and line down. Now normally you know you've got it right because they line up really nicely, and generally they do. They don't always perfectly, but if you have a situation where they line up really nicely, you know you've probably got it right. Then we add the 12 and the 24 together, so that's 36, and that will give us our upper quartile. So draw a line across and down, another one that's lined up really nicely, and that gives us 20. So we've got our lower quartiles of 4, median at 10, and then upper quartile at 20. So we're going to plot that onto our box plot. Okay, so the lowest amount, we put a little notch. Doesn't have to be a very big notch. And our highest amount, which is 42, we put a little notch like that. Okay. Then our upper quartile, our lower quartile, let's start with lower quartile. We can do a slightly bigger line. So I'll try and make these symmetrical a little bit. So that's fine. It doesn't really matter how long you do it, as long as you make it long enough that it looks like a box at the end. Our median is at 10, so we do a little line there. And our upper quartile is at 20, so we do a longer line there. Now it is a box plot, so we do need to make that box. So we put our box in. So, and then we need to join these up. Like that. And that's our box plot. Simple. Okay, next we're given another box plot, and this is about Tuesday's trains. The one we drew was about Monday's trains, and it asks us to compare the distribution of the delays on Monday with the distribution of the delays on Tuesday. Now, with these questions, there's always going to be either 2 or 4 marks, And the 2 or 4 marks are always for comparing the same two things. Whenever you've got a box plot, or two box plots, or a box plot and a cumulative frequency graph, the two things you compare will be the medians and a range, a measure of spread. I always pick the interquartile range, but you don't need to. You could just pick the normal range. So the first thing I'm going to write is that, I'm going to first of all compare the median. So the median is 10 on the first one and 9 on Tuesday. So 10 on Monday, 9 on Tuesday. So I just write the median, what's this about? Delay on Monday was larger than on Tuesday. Fine. And you could say on average the delay on Monday was larger than Tuesday. I would also, I'm not going to, but I would also put the actual times in. So maybe I'd say Monday 10 in brackets and Tuesday 9. Just show the examiner that you know what they are. And that's sometimes a requirement on some exams, that you actually write down the values as well. So I will always compare the interquartile ranges. I don't really know why, but I always do. As I said, you could pick the just normal ranges. So interquartile range here, that's 20, and that was 4, hopefully. Let's just check on my graph. Yeah, 4. So 20 take away 4 to find the interquartile range is 16. This is 17. This is 10, 9, 8, 7, 6. So 17 take away 6 is 11. So we just need to write the interquartile range, and you can actually write IQR on the exams. It's quite a common thing to write for interquartile range. The interquartile range of delays on Monday. Let's put the value in 16. Was larger than on Tuesday, which was 11. Now, really important to also note that this interquartile range, the lower it is, the more consistent the train is. So on many different fields in the world, having a low interquartile range actually makes them more reliable. Yes, they might be delayed by a larger amount or a smaller amount, but if you've got the interquartile range down, that's a good thing, especially for trains, so that you can kind of factor in the delay of the train, and you know it's roughly always going to be 11 minutes late, rather than it's sometimes 2 minutes late, sometimes 20 minutes late. So having the interquartile range normally smaller is better because it's more consistent. But obviously with delays, having the average, the median average larger is not good, generally speaking. Okay, so next question, or the last question. Mary said the longest delay on Tuesday was 33 minutes. This means there must be some delays of between 25 minutes and 30 minutes. Is Mary right? Okay, so if we look up here, so Mary's basically saying that there must be some delays between 25 and 30. Let's try and draw that better. 25 and 30. So it's kind of this region here, okay, on the box plot. Well, we know that a quarter of the delays were between the upper quartile and the maximum. Okay, that's what a quartile means. It's a quarter of them were there. But there's nothing to indicate that they're in that kind of shaded box that I've just drawn. They could be between 17 and 25, or they could be between 30 and 33. We don't know where they are. Okay, all we know is a quarter of them are between 17 and 33, but where they are, the location of them, we don't know. And that's all you need to write, is that the delays could have been between 17 and 25, or 30 and 33. Now, be really careful with this question, and I know you're probably sick of me saying this, but always make sure you answer the question. It says, is Mary right? Well, that's a yes or no question, so I'm going to just write so no. Make sure that a yes or a no is in our answer to make sure you get the full marks you deserve. That's going to do it for us today, so thank you very much for watching this video. If you found it useful, please click like. If you want to see more from us, we release videos every single weekday, Monday to Friday at 9 o'clock in the morning. So just click subscribe and the bell icon to make sure you're up to date with all the stuff we release. If you want to see even more from us, which I'm sure you do, click on the link that's magically appearing above the video now. That will take you straight through to our free website, onmaths.com, which is packed full of free resources to help you with your maths going forward. Otherwise, thank you very much. I'll see you tomorrow.